So welcome student in new topic, that is the linear differential equation where particular integral by general method. As we know, the linear differential equation we can write in symbolic form as f of d operating on y equal to f of x. And the solution of that differential equation in two parts, that is a CF and PI, means y equal to CF plus PI. What is CF? Complementary function, and PI is a particular integral. And we know how to find CF, means first find the auxiliary equation, then the roots, and by using that roots we can write the complementary function. So here is that method, means there are four types, that is the if roots are real and distinct, real and repeated, complex and distinct, and complex and repeated. So we can write CF. And to find a particular integral, there are three methods. First is general method, second is shortcut method, and third is method of variation of parameter, means variation of parameter method. So here today we are going to see the general method, means how to find particular integral by using general method. Note that here particular integral, that is yp equal to 1 upon f of d operating on f of x. Don't forget, the general form of the differential equation is nothing but f of d, means it is a function of d operating on y equal to f of x. So this f of x means this one, and this f of d means coefficient of y, whatever that. So note that here Pi is a function of x only, it does not contain any arbitrary constant. Before to consider the general method, you must note something, that is a 1 upon d operating on y equal to integration of f of x dx. It means that whenever a single d there in denominator, then directly take integration. As we know, if d is in numerator, then it is a derivative, and it is in denominator, it is a integration. Second, 1 upon d minus a f of x equal to, note that here e raised to x and e raised to minus x, how it behave, means here minus ax, this minus, so that is why minus ax inside and plus ax outside. So I can remember it easily, that is the same sign, means minus, then minus e raised to minus ax, it is inside, and e raised to x outside. If plus a means here d plus a, so same sign inside, it means that e raised to plus ax inside, and opposite sign outside means e raised to minus x outside into f of x dx. So 1 upon d minus a operating on f of x equal to e raised to x integration e raised to minus ax f of x dx, means 1 upon d minus a operating on f of x equal to e raised to x integration e raised to minus ax f of x dx, and 1 upon d plus a operating on f of x equal to e raised to minus ax integration e raised to x f of x dx. The particular integral pi of the linear differential equation f of d operating on y equal to 0, it means that if right hand side is 0, then pi equal to 0. Then the general solution is y equal to only yc, means CF. It means that it is very easy, that is f of x equal to 0 if we put, so this value equal to 0. So whatever that d plus a or d minus a here. So by partial fraction means what? Means if pi equal to 1 upon f of d operating on f of x, and then if we can factorize this f of d in the form of d minus a, d minus b, supposed to be there are some factors, then we can separate this by partial fraction. So how? 1 upon a minus b into 1 upon d minus a f of x minus 1 upon d minus b f of x. Remember this formula directly. One can use here the method partial fraction a upon d minus a plus b upon d minus b, and then find the values of a and b. But by this formula you can find directly 1 upon d minus a and 1 upon d minus b here operating on f of x, and then by using these nodes we can find the value of this. How? you just consider this here. For first part, this one, I can use this formula. So I am getting like this. Similarly here, I can use same formula and I am getting this one. So this integral solve, and we will get particular integral or required solution. So this way. Now example on linear differential equation by general method. So consider one example. Solve d square y by dx square plus dy by dx equal to 1 upon 1 plus e raised to x. So how to solve this one? So first, given differential equation you write in symbolic form, that is a d square, means here in symbolic form d square plus d operating on y equal to 1 upon 1 plus e raised to x. Then we know the general solution is what? Into two parts, that is CF plus PI, that is equal to YC plus YP. So equation number 1. Now one by one we have to find. It means that we have to find CF, we have to find PI. As we know how to find CF, that is the roots of f of d. So what is the here step number 2 for CF auxiliary equation is f of d equal to 0. Means what is f of d here? Means coefficient of y, it is a d square plus a d, that is equal to 0, and find the roots of this. So I can common out d. So d into d plus 1 equal to 0, and I am getting here d equal to 0 and d equal to minus 1. So 0 and minus 1 both are real and distinct, and that is why we know how to write CF is yc equal to c1 e raised to first root, that is the 0x plus c2 e raised to second root, means minus x. So as e raised to 0x is 1, so I can write that is equal to c1 plus c2 e raised to minus x. So this is the first part of our solution. Now what about the second part, that is the PI. So step number 3, to find PI, we can write PI means yp equal to 1 upon f of d operating on f of x. So what is it? 1 upon d square plus d operating on 1 upon 1 plus e raised to x. So here instead of partial fraction, I am using 1 by 1. How? So here 1 upon d I will take outside, and only 1 upon d plus 1 operate on this f of x. So what I am getting here? 1 upon d plus 1 operate on 1 upon 1 plus e raised to x. So by the formula, as we know, 1 upon d plus a or d minus a operating on f of x, we know. What is it? For example here 1 upon d plus a operating on f of x, same sign inside, opposite sign outside. It means that plus a is inside. So e raised to ax inside and e raised to minus ax outside. So I am getting 1 upon d plus a f of x equal to e raised to minus x integration of e raised to ax f of x dx. So in this case, what is a? So in this case, a is nothing but plus 1. So e raised to x inside, e raised to minus x outside. So I am getting here 1 upon d outside as it is, and e raised to minus x integration of e raised to x into f of x means 1 upon 1 plus e raised to x. Now our job is how to evaluate this one, this integration. You must go through the list of integration. So here you can see denominator is 1 plus e raised to x and numerator is e raised to x. So what is the derivative of denominator? It is the e raised to x, it present in numerator, and we know that formula. What is that? So integration formula is nothing but integration of f dash of x upon f of x dx equal to log of f of x, and that is why I am getting. So this as it is, and only this is nothing but log of denominator. So what I am getting? So I am getting here yp equal to 1 by d e raised to minus x, it is as it is, and log of 1 plus e raised to x. Now again 1 by d operating on f of x, as we know the standard formula, if 1 by d directly integration. So since 1 by d operating on f of x equal to integration of f of x, so directly take the integration of e raised to minus x log 1 plus e raised to x dx. So use here uv rule, means integration by parts, integration of uv dx equal to u into integration of v dx minus integration of derivative of u into integration of v into dx. So that formula you know, and that is why I am getting here. I am going to consider this is u. and this is v. So u as it is, log of 1 plus e raised to x, and integration of e raised to minus x is e raised to minus x by minus 1 minus integration of then derivative of this one. What is derivative of log? This 1 upon 1 plus e raised to x into derivative of this one is e raised to x. So I am getting e raised to x upon 1 plus e raised to x, and integration of this one is e raised to minus x upon minus 1. So simplify this. So I am getting this minus outside, so plus here e raised to x and e raised to minus x. Here I am getting e raised to 0x, that is nothing but 1. So simply I am getting, so this as it is, first term. So this is a minus e raised to minus x log of 1 plus e raised to x. This minus and this minus become plus now, and here I am getting simply 1 upon 1 plus e raised to x. So note the adjustment now. What is that adjustment? So first part as it is, and here only 1 is there. So I am just adding e raised to x and subtracting e raised to x. So due to that I am getting this is 1. If we separate it, so this divided by this, it is 1 minus e raised to x upon 1 plus e raised to x. So what I am getting? So I am getting here minus e raised to minus x log of 1 plus e raised to x, this as it is, and here separate it. It means that 1 plus e raised to x upon 1 plus e raised to x, it is nothing but 1 minus e raised to x upon 1 plus e raised to x. So here same thing I can write like this, and now again the integration, same formula which we already used here, integration of f dash of x upon f of x dx equal to log of f of x, because derivative of this present here, and that is why I am getting. And what is the integration of 1? It is just x. So I am getting final answer is e raised to minus x, this minus sign as it is there, log of 1 plus e raised to x plus, what is the integration of 1? It is x, and it is a log of denominator means 1 plus e raised to x. So this is your yp, means particular integral, and we have now yc and yp. So what is the general solution, means complete solution here. So step number 4 from equation 2, 3, the complete solution is y equal to c1 plus c2 e raised to minus x, means that is equation number 2, and equation number 3 is pi or yp, that is minus e raised to minus x log of 1 plus e raised to x plus x minus log of 1 plus e raised to x. One may simplify more but not necessary. So this is your required answer. It means that I can take this common, log 1 plus e raised to x. So I am getting minus also common, and here e raised to minus x and here plus 1. But simplification not necessary. This is also your last step. Now consider one more example on the same, means general method. It will be more clear. Solve d square plus 5d plus 6 operating on y equal to e raised to minus 2x sec square x into 1 plus 2 tan x. So as we know, that is the given differential equation you write, and general solution in two parts, that is nothing but yc plus yp. So I can write this step number 1, this is yc and yp. So how to find yc? That we know step number 2 for CF auxiliary equation is coefficient of y, put 0, that is your auxiliary equation f of d equal to 0. So what are the factors? Here 6 and here 5. It means that factors are here d plus 3, d plus 2. So I am getting here d equal to minus 2 and d equal to minus 3. Both are real and distinct, and that is why I am getting yc equal to c1 e raised to minus 2x plus c2 e raised to minus 3x. Sequence doesn't matter. Note that. To write the CF, sequence doesn't matter. One may consider minus 3 first and then minus 2. Now particular integral, that is the general form. As we know, yp equal to 1 upon f of d operating on f of x. So what is here f of d and f of x? Here 1 upon d square plus 5d plus 6 operating on f of x means e raised to minus 2x sec square x into 1 plus 2 tan x. What are the factors? Here d plus 3, d plus 2. Note that here I can use here partial fraction, means I can separate this and then separately I can operate here. But here instead of that I am using 1 by 1. Means what? For the first factor I will operate on the f of x. So I am getting here this 1 upon d plus 3 as it is, and 1 upon d plus 2 operate on f of x. So I am getting here this much. As we know the formula, what is that formula? 1 upon d plus a operating on f of x is what? That is equal to same sign inside, opposite sign outside, and that is why I am getting here e raised to minus x integration of e raised to x into f of x dx, and I am getting here 1 upon d plus 3 as it is, and due to this plus 2, so this e raised to 2x inside, e raised to minus 2x outside, and now simplify. Note that by this 2 I am getting e raised to 0x and it is nothing but 1. So what is remaining? Only sec square x into 1 plus 2 tan x. So I am getting only this one. Now integrate this sec square x into 1 plus 2 tan x. So how to integrate it? So again I repeat it, you must know the methods of integration and list of integration also. So here I am just taking the adjustment. How? This is 1 plus 2 tan x and sec square x. So I am taking here 1 by 2 and this 2 here. Note that 2 here and 1 by 2. Why? Because I am using here the formula, this one. If function and derivative present, then that is equal to f of x whole square by 2. So here what is the derivative of this one? It is nothing but 2 as it is, and derivative of tan is sec square x. So I need that 2. So that 2 is not there, so that I am going to adjust. 2 inside and outside 1 by 2. So note this adjustment. So here I am getting directly what is f of x? F of x is here. This is f of x. This part is f of x. Square of this by 2. So I am getting this much. So simplify it again. So I am getting 1 upon d plus 3, 1 by 2 and this 2. It is 1 by 4 e raised to minus 2x into 1 plus 2 tan x whole square. Now again this 1 upon d plus 3 operate on this. So I can use same formula here. How? So I am getting here same sign inside, opposite sign outside. So what is this outside? Here d plus 3 means same side, plus 3x, e raised to plus 3x inside and e raised to minus 3x outside. So I am getting here this much. So I am getting here this 1 by 4 e raised to minus 3x integration of e raised to 3x, and f of x is already there, e raised to minus 2x into 1 plus 2 tan x whole square dx. So I am getting e raised to minus 3x. So note the case here, this simplification, e raised to 3x, e raised to minus 2x, I am getting e raised to x, and inside square of this, so take the square of that, and I am getting, that is, you know, a plus b whole square, that is a square plus 2ab plus b square. So I am getting here 1 by 4 e raised to minus 3x integration of e raised to x into 1 plus 4 tan x plus 4 tan square x dx. Now how to evaluate this one? I will use this formula, e raised to x into f of x plus f dash of x. So I want function and derivative. So what is the, if we consider this part, so I am getting here 4 sec square x. So you convert this tan square x into sec square x. How? As we know, 1 plus tan square x equal to sec square x. So that formula I am using here, and that is why I am getting here 1 plus 4 tan x, this as it is, and 4 tan square x is sec square x minus 1. So simplify. So I am getting here this 1 by 4 e raised to minus 3x integration e raised to x, this as it is, and here 4 tan x plus 4 sec square x minus 3. Now I want derivative and function, that is f of x plus f dash of x. Note that derivative of this is present there, and this 3 I will adjust with this one. So what I am getting by this adjustment, note these steps, right? So here I am getting 1 by 4 e raised to minus 3x into integration of e raised to x as it is, and here I am taking this together. And what is derivative of this one? It present there, and that is why note this thing. I am getting this f of x and f dash of x present, and using the result that I already said, that is e raised to x f of x plus f dash of x, then that is equal to e raised to x f of x. So what is here e raised to x and what is f of x? It is a 4 tan x minus 3. So I am getting. So that is why answer is here 1 by 4 e raised to minus 3x, and integration is e raised to x and f of x is 4 tan x minus 3. Simplify it and it is your yp. So 1 by 4 e raised to minus 2x, 4 tan x minus 3. Because this minus 3x and this x, I am getting e raised to minus 2x. So now we have yc and yp. So collect this one and we can write the general solution of it. What is it? So from equation 2 and 3, the complete solution one is yc plus yp. So what is yc? c1 e raised to minus 2x plus c2 e raised to minus 3x plus here pi 1 by 4 e raised to minus 2x into 4 tan x minus 3, which is your required solution. Consider one more example. So getting the things, if yes, now continue. One more example on it, that is solve d square plus 3d plus 2 operating on y equal to e raised to x. So again the up to the CF it is same. Given the differential equation, you write it here in symbolic form. If not, so it is already in symbolic form. We know the general solution is yc plus yp. So note that here we know here y equal to yc plus yp. So one by one we have to find. So first is CF, that is the auxiliary equation. To find CF, that is nothing but f of d equal to 0, means coefficient of y equal to 0. And what are the factors of this one? So we can factorize it as d plus 2, d plus 1. And I am getting here roots of d are minus 1, minus 2. Both are real and distinct. And that is why I can write CF as c1 e raised to minus x plus c2 e raised to minus 2. So I think up to CF, no doubt. Is it? Now the particular integral. What is the particular integral? Next step, that is particular integral is yp equal to 1 upon f of d operating on f of x. So what is f of d here? D square plus 3d plus 2. That is 1 upon d square plus 3d plus 2 operating on f of x means e raised to x. So I am getting here factorize of this one, that is factors of this one, that is the d plus 2, d plus 1, and now by partial fraction. So here I am using a partial fraction. Note that the same method I can use here, that is 1 by 1 operate, but here I am taking partial fraction, and by partial fraction I am getting directly by this formula, or you can use here a upon d plus 2 plus b upon d plus 1, and that is equal to, as you know how to find value of a and value of b. So you can use that method also, but I am taking a direct formula and I am getting 1 upon d plus 1 minus 1 upon d plus 2 directly operating on e raised to x. Separate it. So what I am getting? I am getting here 1 upon d plus 1 operate on e raised to x minus 1 upon d plus 2 also operate on e raised to x. Again using the same formula. What is that? 1 upon d plus a operating on f of x, same sign inside, opposite sign outside. So that is why I am getting here, if we operate for the both, I am getting e raised to minus x integration e raised to x dx minus for the second, same sign means e raised to 2x inside, e raised to minus 2x outside. So I am getting this one. Now how to integrate it? Again the problem is with integration. So without fail, you must go through the all integration methods as well as list of integration. Note the adjustment here. For the second, this one e raised to 2x, I am just splitting it e raised to x, and I am putting here e raised to x equal to 2 t. What I am putting here? e raised to x equal to t. Note that it is always simple. If suppose e raised to any function here, it is not simply x, then whatever this one, it is a substitution. So here that problem itself suggests us that substitution is e raised to x, and that is why I am splitting this e raised to 2x into this e raised to x, e raised to x. So that is why I am getting here e raised to x equal to t. So e raised to x dx equal to dt, and I already said that you always find space for dt. So what is the space for dt? So e raised to x dx, this is the dt, and here e raised to x dx, it is the dt. So what we get here by after substitution, I am getting here e raised to minus x as it is, integration e raised to t, and remaining is dt minus e raised to minus 2x as it is, and here this is a t and this is e raised to t, and this is dt. Now how to evaluate it? This in the second part, second term, here t into e raised to t, use here integration by part, uv. So I am getting here integration by parts. So first you can see what is the integration of this one, e raised to t directly, and here u into v rule. So first constant, integration of second, minus integration of derivative of first, integration of second, and dt. And what is the integration of e raised to t dt? It is again e raised to t. So same thing I can write like this. So I am getting this much. So what is e raised to t? As we know, t equal to e raised to x. So substitute here. So I am getting this much. And here simplify. So if we simplify this, e raised to minus 2x inside, so I am getting here this e raised to minus x, e raised to x as it is, and here minus e raised to minus x, e raised to x plus e raised to minus 2x, e raised to x. Note that these two cancel, plus minus, and that is why your yp is simply e raised to minus 2x into e raised to x. Now collect the CF and PI. So you will get the solution, that is the complete solution is CF plus PI, that is C1 e raised to minus x plus C2 e raised to minus 2x plus PI is e raised to minus 2x, e raised to x, which is your required solution. So this is your final solution. If you want, you can consider this example also. That is here the special thing, that is the sine and cos contains e raised to minus 3x. So here CF we can find very easily. How? That is the d square minus 2d minus 3. You just factorize, and I am getting here two factors as d minus 3, d plus 2, and roots are real and distinct, and that is why yc equal to c1 e raised to 3x plus c2 e raised to minus x. What about the pi? Particular integral, you write there 1 upon d square minus 2d minus 3 operating on it. So I am getting here factors d minus 3, d plus 1 operating on f of x. So note that this is a special example because here adjustment. So what is that adjustment? Note the things. So I will operate first 1 upon d plus 1 of f on f of x. So I am getting this much, and using the formula, again the same formula I can use, that is the same sign inside, opposite sign outside, and I am getting this much. But here when we are going to consider e raised to x into something, we already know one formula, that is nothing but e raised to x inside f of x plus f dash. If we are able to write here f of x plus derivative of it, and here sine and cos, it may give us the derivative and a function. So that is why I am trying here. Note the steps here. This adjustment is nothing but this. I am going to consider f of x is cos e raised to minus 3x. So what is derivative of it? It is a minus sine e raised to minus 3x into derivative of this is minus 3 e raised to minus 3x. If we simplify this, it will get 3 e raised to minus 3x into sine e raised to minus 3x, and that is why I can consider here function and derivative. Getting? And that is why by using this formula directly I can write it is a integration of this much is f of x e raised to x into f of x. And now simplified, so I am getting here 1 upon d minus 3 operating on simply cos e raised to minus 3. Note this adjustment. This is very important step here. Now again the same formula I will use and same sign inside, opposite sign outside, and it is now very simple because cos of some special thing. If cos of sine of means any trigonometric exponential and logarithm with x, then okay. But if supposed to be something extra, for example here trigonometric function into that trigonometric means cos of e raised to minus 3x. So that substitution is nothing but e raised to minus 3x. So problem itself suggests us e raised to minus 3x is the substitution, and now the remaining thing you can just find by this way. So here d, find this space first, that is e raised to minus 3x dx, that is nothing but dt by minus 3, and now just the integration of cos t is nothing but sin t. So I am getting here minus 1 by 3 e raised to 3x sin t, and what is t here? T is e raised to minus 3x, and that is why it is your yp, and hence the complete solution is yc plus yp. So this is your complete solution. Note the general method to find a particular integral. Okay, in the next video we will consider the examples on particular integral by shortcut methods as well as variation of parameters.